All right, welcome to Chapter 9, Section 5, Parts of Similar Triangles. This is for Integrated Math 2 or IM2. So a couple things before we get started on our problem here. The first thing you should see is your due date. I don't see that on the teacher preview, but you'll see it on your student side. The second thing is the number of attempts. We always have unlimited attempts open for homework, tests, and quizzes. Number of questions for this one, and just shows you how many are on this assignment. Grading policies, best scores, whichever attempt is the best one to keep. Partial credit is enabled. Usually we have more than one question, so we would kind of reference if you answer one of so many questions correctly, you get credit for that one question. In this case, it would be kind of partials within the question if there's more than one answer that we're going for there. But a lot of the time you're going to have to answer the entire question and get credit here. Down here it says, please remember, once you start your homework, you must finish before you can work on anything else. What that means is once we click start, down in the bottom right corner, we will see a Submit Assignment button. That is how we finish our assignments. So when we want to leave the screen, we don't want to click X, we don't want to close our computer down, we want to click Submit Assignment. So in this case, we're going to probably want to finish the entire assignment before clicking the Submit Assignment. We want to click Check and then Submit Assignment because we might be able to get partial credit for either answering one of the two. And it may save our place there if we've clicked check and we've gotten one of them. But a lot of the time I think it will open a new one because the problems themselves don't save partial information like that. So make sure you click the Submit Assignment button, but try to finish this one off since it's only one question. It also affects the gradebook when you click Submit Assignment. That's the other big reason to click this one, because we don't want it to freeze our accounts. That's what it means by not letting you work on anything else. It locks you out of everything. And then it also freezes the gradebook. It doesn't let you update that, and it doesn't let your teacher see what you've been working on. So always click that button. On the side we have Explanation, Example, and Message Center. So Explanation tells you you're going to lose a question attempt because it's going to give you the answer to this question. So we don't get to see the answer and then get to come type it in. But we can see an example. And for this one, so we have these two triangles here. And we're told to find the value of each variable. And what we want to show on these ones is, we're going to go through and look at the background here. So triangle, angle, bisector theorem. So the angle, or the triangle, is bisecting these angles. And I can see that because I have one arc. That's a bisector, meaning that these two are equal. And then I have two arcs and two arcs. So this is another bisector. So it's cutting the angle in half. So coming from the vertex, cutting the angle in half, and then just coming over the third side. So it's not necessarily coming over the third side in any particular place, but it does divide it proportionally. So if in a triangle, an angle bisector separates the side opposite the bisected angle into two segments whose lengths are proportional to the lengths of the other two sides. So with this one, and I'm just gonna steal the diagram here because it's a little easier to do if I have a diagram to go off of instead of trying to draw that on my own. There we go. All right, let's maximize that guy a little bit. So it's talking specifically about this angle here, or this line here. It's gonna cut the triangle into some kind of proportions or proportional lengths. So we can see for the first triangle here, then they're just giving us an example. BD, so BD, this length here, and CD. So the first segment over the second segment, and then AB over AC. So the way I kind of like to picture this when I'm thinking of it is we have this red line, this divider, and I want to go over the it'd help if I turn the line tool off, wouldn't it? I want to kind of go over the divider like this. So I have one segment over the other, and then from that same corner I want to go over the divider again, but kind of over the top, or the vertice. So I have this segment and then this segment. So for whatever reason that helps me remember the order that I can put these in. So when we're looking at these two, we're going to answer them separately because they're two different triangles. The triangles don't actually talk to each other in any way. They're not proportional to each other. We have no information that they're similar triangles. So we're going to have a proportion for one triangle and a proportion for the second triangle. So we're going to solve both of them. and they don't necessarily have anything to do with each other than they're both having an angle bisector. All right, so let's actually get our real diagrams over there. Come on, where is it? There it is. Took a minute. Okay. So we have our angle bisector here, so I can see it's bisecting this angle. Boom. And this one is bisecting this angle. I know I'm making them both red. I'm just kind of trying to make them stand out. Doesn't mean that they relate to each other necessarily. They just stand out. So the proportion for the first one, if I want to find x, remember I'm going to pick a vertice and I'm going to move from that vertice. So I'm going to go from here and I want to move over. So it's going to be the first length over the second length. So that would be 8 over x. And then from that same vertice, I'm going to do the same thing. I'm going to move over, and I know it's kind of a weird loop there, but I'm moving over. So it's the first length over the second length, which is 3. So now I can go through and do some cross multiplication here, and I can solve this. 8 times 3, well, that's 24, equals x times 9, which is 9x. And I can divide by 9 on both sides. And with this one, I can see that they're giving me some fraction bars, so I'm going to end up with fractions. Let's see, they can, 24 over 9 equals, and 9 divided by 9 cancels, but I can reduce this because they can both divide by 3, so this is going to become 8, this is going to become 3, so it's going to be 8/3. And I believe they'll let me leave it 8/3 instead of turning it into a fraction, because I don't really want to do any rounding, or not into a fraction, sorry, into a decimal. If I turn this into a decimal, then it would definitely give me a repeating decimal since I'm dividing by 3. But I could turn it into a mixed number because 3 can be taken out twice there, and I would be left with 2. Yeah, so 2 2/3 would also work. I'm not sure if 8/3, in fact, I'm just going to go ahead and try to see if they would let me leave it as 8/3. If not, we'll fix it and we'll make it a proper fraction. All right, let's do the next one here. So we have our divider here, so we're going to go across. I'm just picking this vertice. I could have picked the other one. It really doesn't matter. So I have 2 over 4, because first length over second length, equals, now I'm going to go over this one, first length over second length, so 3 over y. And now that I have it set up, I can go ahead and start solving. So I have 2y equals 12, and if I divide by 2 on both sides, I get y equals 6. So this one I don't have to worry about reducing, it's just 6. So let's see if it, yeah, so it wants me to do the mixed number, I believe. So let's try it again. Oh, doesn't like the mixed number either. Did I do some math wrong? Let's see. Oh, I just realized I'm not even paying attention to the diagram, am I? 8's the entire length. Ooh, tricky, tricky, tricky. They're being a little silly with that. So let's see. I'm going to erase this guy here. Too much erasing. Okay. I'll just leave some of that stuff there. So the first length is not 8. It's 8 minus x over x, which is the second length. I wasn't even paying attention that 8 went the entire length. Whoopsie. And then 9 over 3. So now, if I do my cross multiplication, remember this means 8 times 3, which is 24, and 8 times x, which is 3x, negative 3x, because it's negative x, equals 9x. So now I'm going to add 3 to both sides, and I get 24 equals 3x minus 3x cancels, and 9, 10, 11, 12. Oh, see, it's going to end up being a whole number. So 24 divided by 12 is 2. 12 divided by 12 cancels, so I get 2 instead of 2/3. I wasn't even noticing that went the whole length. I should have been paying attention on this diagram, but for whatever reason, when I drew my line, it cut my sight out, and for some reason I was just thinking 8 was this small segment here. Alright, so there we go. So just making sure we're paying attention to diagrams. Do mistakes happen? Of course they do. Just go back and take a look again and make sure that we read the diagram correctly. It's not a big deal. And we all make mistakes, obviously. So that was section 5. I believe I will see you in section 6.